All right, good morning, everyone. I wanted to do a quick refresher on composition of functions before we got into our notes tomorrow over inverse functions. A composition of functions is basically where you're plugging a function into another function. We're going to see a little bit of a different notation today. We're going to see like G open, a little open circle F. That means G of F. If you kind of look, I know it's slightly blurry, but hopefully you can see this okay. So G open circle F of X would be the same thing as G of F of X. And this notation here on the right side of this equal sign should look familiar. We looked at this a little bit back in chapter 2. I know it's been a bit. But basically the idea when you're doing a composition of function is you kind of work inside out. So you figure out what the inside function would equal, and then you plug it into the outside function. If you kind of look at what it's saying here, it's kind of showing you that. So we're going to look at just a few examples. Like I said, I just wanted to kind of make sure this was a little bit fresh on our minds before tomorrow's notes, because it should help us a little bit with some of what we'll be looking at. So let's say we have two functions. We have f of x equals x minus 5, and we have g of x equals x squared. They're asking us to figure out what f of g of negative 3. What this means, just so we're clear, this would be f of g of negative 3. Like that's what this notation means. So on the right-hand side, this might look a little bit more familiar, but you could come across either of these notations like on a standardized test. So if you're taking like your ALEKS test and you saw a question like this, I'm not sure if they'd use the notation on the left or the notation on the right. I mean, different textbooks, it's just kind of a coin flip which notation they prefer. So like I said, we want to work inside out. So I want to figure out what g of negative 3 is. So if I plug negative 3 into my g function, well, negative 3 squared would be positive 9, because remember, negative 3 times negative 3 would be positive 9. So really this is f of 9. And then we're just going to plug that into my inside function. So f of 9 would be, well, if I look at my f function, that's x minus 5. That would be 9 minus 5, or just 4. So f of g of negative 3 would be 4. How about you guys try question B? What if it was g of f of negative 3? How would you work this out? If it kind of helps you to get started, remember how you would write this. This is g of f of negative 3. So take a second, see if you can figure this one out on your own. All right, so if you gave this problem a try, if you figured out your inside part, f of negative 3, like if you plug that into this f function, you would have negative 3 minus 5, that would be negative 8. So really you have g of negative 8. So then if you look at the g function, negative 8 squared, if you're putting it in a calculator, make sure you gotta put those parentheses. But you would get positive 64, because negative 8 times negative 8 is positive 64. All right, and then I just wanted to look at a couple more examples of composite functions where we're looking at a variable. Say you had f of g of x. All this means is you're gonna, I mean, since we're not plugging in a value, we're just gonna, what is g of x? Well, g of x, I'm just gonna write that up here. G of x is x squared. So basically I'm gonna plug x squared in for x in my f of x function. So basically anywhere in this f function, I see an x. Oops, let's try that again. I'm gonna replace that with an x squared. So I would have x squared minus 5. And there's nothing we can do to simplify that from here. Like sometimes you might be able to like combine like terms or do something more, but for this one, we would be done. So just keep in mind, if you're plugging in an x, you're going to get an X for your final answer. Let me just kind of, oops, section these off a bit from each other. But how about you guys try question D, g of f of x. So remember, that would be like, you could write that like this. So give this problem a try. All right, so hopefully we'll see how you did, but you would have g of, well, f of x is x minus 5. Since we're not plugging in a value, we're just writing what the function is. So you're going to replace any x's in the g function with x minus 5. So this would really turn into x minus 5 up to the second power, which you could FOIL out. Remember, that's this. So if you FOIL that out, that would be x squared minus 5x minus 5x plus 25. So if you condense that down, you would have this. And we'll see how this kind of comes into play with inverse functions. We're going to see sometimes you can use composite functions to either check if two functions are inverses. So it's just a skill I wanted to make sure that was a little fresh on our minds, so I didn't totally catch you off guard tomorrow if I bring it up. But I hope you guys have a good day, and I hope this wasn't too bad of an assignment on your Wednesday.